Hello and welcome to a short video about index laws. In this video we'll summarise all 6 key index laws that you need to know. So you need to remember that indices are basically powers. So 5 to the power 3 is 5 times 5 times 5, 8 to the power 4 is 8 times 8 times 8 times 8 and so on. Using these laws does make it easier to answer questions. We use it in various things. Differentiation is a key one that we will be thinking about in our GCSE and A-level maths. So if we think about multiplying, so I've got something like x to the power 3 times x to the power 10. Now the answer to that is x to the power 13. And y to the 10 times y to the 6 is y to the 16. Now basically what we're doing here is we're adding those powers. So x to the power m times x to the power n is equal to x to the power m plus n. Now this only works if you have the same base. So if I had something like this, x to the power 3 times y to the power 4, I can't simplify that. I can't add those powers to make 7. That just stays as x to the 3, y to the 4. If we think about it just slightly differently, a to the power 3 times a to the box equals a to the 10. Well, in the box I'm going to have 7, because 3 plus 7 is 10, and I'm adding those powers. We can do it with various letters as well, something like this, ab to the 3 times a to the 5b squared times abc squared. I'm going to look at my a's first, so I have an a here, a to the 5 here, and another a. So that's a to the power 7. I also have, if I think about the b's here, here, and here, so I have b to the 3, so that's 3, b squared, so that's 5, and another b, that is 6. So that's b to the power 6. And I have a c squared because there aren't any c's in the first two parts. Now you may wonder why this is working. If I think about something like this, x to the power 4 times x to the power 3, x to the power 4 is x times x times x times x, and x to the power 3 is x times x times x. So we can see there I have 7 x's all multiplied together. So I'm going to get x to the power 7. Okay, so law 2 is when we divide. And this is obviously the opposite of multiplying, as dividing is the opposite of multiplying. So it probably won't surprise you to realise that this is x to the power 7, and this would be y to the power of minus 3. What I'm doing here, so I have x to the m divided by x to the n, that's x to the m minus n. And again, it's fairly logical why that works. If I have x to the power 6 divided by x to the power 2, that's the same as x times x times x times x times x times x over x times x. And using my normal rules for dividing fractions, I can cross out some of those x's to get x to the power 4. We can use the rules in conjunction with each other. So a to the power 6 times a to the power 4, all divided by a to the power 3. Now thinking about law 1, that's the same as a to the 10 over a to the 3. And using what we just looked at, that is a to the power 7. With brackets, we have quite a similar thing that's going on. This is going to be x to the power 12. And again, if we think about what's happening, that's x to the power 4 times x to the power 4 times x to the power 4. Because we've got brackets around it, the whole thing is raised to that power of 3. So I have to do x to the power 4 times x to the 4 times x to the 4. If we think about what's going on there using law 1, that is going to be x to the 12, because I've got 4 plus 4 plus 4. 3 lots of 4, which is obviously x to the power 12. The same sort of thing is going to happen here. I've got y to the power 6 in brackets to the power 10, so that's y to the power 60. Now sometimes we'll have 2 letters or a number and a letter inside the bracket. And what we have to do here is raise everything inside the bracket by the number on the outside. So this is going to be 3 to the power 4, a to the power 4, which is obviously 81, a to the power 4. The same sort of thing will happen here, where I've got these different letters. So I've got 10 squared, a squared, b squared, which is 100, a squared, b squared. Now a question like this one here, x to the power, so 8 to the power 10 is equal to 2 to the power something, is a brackets question, it's just hidden. What I need to do, and if you remember back when we looked at law 1, I said it's important to have that same base number. I need to think about 8 as a power of 2. 2 to the power 3 is equal to 8, and the reason I want it as a something as a power of 2 is because I've got a 2 over on the right hand side as part of the answer. So if 8 is 2 to the power 3, I'm raising that whole bracket to the power of 10. So 2 to the power 3 to the 10 is 2 to the power 30, so 30 must go in the box. That is a type of question that examiners really do like asking because it makes you think about two different laws together and it's sort of a bit hidden away. Now if you're still with me, the good news is that law 4 is quite an easy one. 5 to the power 0 is 1, x to the power 0 is 1, y to the power 0 is 1. In fact, anything to the power 0 is 1. So if I have a question like this, ab to the 0, we know that's the same as a times b to the 0, which is the same as a times 1, which is just a. And we can link the bracket rule here. If you remember, that 0 would need to go to everything. So that's the same as a to the 0 times b to the 0, which is the same as 1 times 1, which is 1. Now, negative powers look a bit odd to start with, but they are, again, fairly straightforward. X to the power of minus 3 is 1 over x to the power 3. Y to the minus 5 is 1 over y to the power 5. What you're doing, the minus tells you to do 1 over, and then the number is the power that it's raised to at the bottom. So x to the power of minus m is the same as 1 over x to the power m. So if you think about this one here, if you remember, everything in the bracket is going to need to be raised to that power of minus 2. So that's the same as 1 over ab in brackets squared. And if you needed to multiply that out, that would be 1 over a squared b squared. Remember, that minus just means do 1 over, and the number is the power you're raising it to. So if I have this one here, 3xy to the minus 5, that's the same as 1 over 3xy all to the power 5. And if we think about that bracket rule, that's going to be 1 over 3 to the power 5. So 1 over 243 x to the 5 y to the 5. Think about a couple more questions here. Again, we can combine the different skills. That's going to be x to the power 6. Remember the bracket rule, 2 times 3 is 6, times x to the minus 10, which is going to be x to the minus 4. So again, remember that first rule, 6 plus minus 10 is minus 4, which is the same as 1 over x to the power 4. Y to the 4 to the minus 6 is y to the minus 24. Now dividing that by y to the 10, again I'm using those brackets, now I've got to divide it to minus, so that's y to the minus 34, which if we needed to put it as a fraction is 1 over y to the power of 34. So then we finish with fractions. Now, x to the power of a half is the square root of x. X to the power of a third is the third root of x. And x to the power of a quarter is the fourth root of x. Now basically what I'm doing here, if I have x to the power of 1 over m, it's the mth root of x. But of course it's not always a 1 over when you're thinking about a fraction. If I have something like this, y to the power of 3 over 2, we are going to do the square root of y and raise that to the power of 3. If we think about our bracket rule, that is also the same as doing y to the power 3 and square rooting it. So again, if we think about this one, I've got a 3 on the bottom, so I know that's going to be the cube root, the third root of y, and the whole thing is being raised to the power 4. We could also think about that as y to the power 4 and then find the cube root. So the same sort of thing is going to happen here. The fourth root of y to the power 5, or y to the power 5, and find that fourth root. So if I've got y to the n over m instead of 1 over m now, what I can always think about that is the mth root of y, all raised to the power n, or if you wanted to, if it's easier, because it is for some questions, think about that as y raising to the power n, and then finding the nth root. And the key thing to remember here, so you remember the way around they go, is roots come from the bottom. So if you think about flowers and trees and so on, the roots are at the bottom, and it's the same here. Our root numbers are at the bottom of the fraction. So we can combine it with our negative power. So a to the minus 2 over 3 is the same as 1 over a to the 2 over 3, which is 1 over the third root of a squared. So b to the minus 5 over 8, same as 1 over b to the 5 over 8. So it's 1 over the 8th root of b to the 5. We can combine it with our brackets rules, so that's the same as c to the power of 3 over 2, which is the square root of c raised to the power 3. 5d to the minus a half is the same as 5 to the minus a half, d to the minus a half, which is 1 over root 5 times 1 over root d, which of course we could simplify as well if it's easier, to 1 over root 5d. So this page just summarises those key index laws that we've just spoken about. I hope that helps. Thanks very much.